This is example 14.8 from Discovering Design with Chemistry. And I think we're almost to the end of this chapter. I think we have one more example after this one. So it says, we just calculated the change in H and the change in S for the following reaction, and it gives us the same reaction we just used in 14.7. And it reminds us of what answers that we got. And it asks for what temperature is the reaction spontaneous. And so for this one, I've kept in the pink box just the pieces of information we need. For this to be spontaneous, what has to happen? In the last thing, it was not spontaneous because G was positive. But if delta G had been negative, it would have been spontaneous. So in other words, this change in H minus T times change in S, if this thing were negative, then it would be spontaneous. So we can just set it equal to be less than 0, and that will make sure that it is spontaneous. All right, so let's just plug in our numbers. So again, this number has to change. So we're going to convert 41.2 kilojoules to just joules. We did this in the last video, so I'm just going to copy it over. So we have 41,200 joules minus T. We can't plug a number in because that's what we're trying to find. We're trying to find what temperature. And then our delta S is 41.9 joules per Kelvin, and that has to be less than 0. Hopefully you've done this in algebra before, so we can just move stuff around. I'm going to go ahead and add this part to both sides, which will clear it out on this side, and move it over here to be on the opposite side. I did that because I wanted both sides to be positive, because when you divide by a negative number, you have to flip the sign, and so I wanted to have both sides already be positive for me. All right, so to solve for T, we need to divide both sides by 41.9. 41.9. And we've done a couple of these, but just to remind you, whenever we do these, this is kind of like it's top of the fraction, so it's as if it's a whole number, so it cancels with this. This K right here is on the bottom of a fraction, which is on the bottom of a fraction, which means it comes out as being the actual unit whole, not on the bottom of a fraction. All right, we're dividing. We have 3 significant digits in both of our numbers, so our answer needs to have 3 significant digits. So we have 41200 divided by 41.9. And the answer we get is, now we get 3 significant digits, so 983 point, and then that 2 is under 5, so we're not going to round up. We're going to round down to just 983, and that's in Kelvin. If they had asked for it in Celsius, we would need to change it, but we don't need to. The way it's phrased is kind of looking a little bit backwards because it's hard to see. Usually you would say the temperature must be, and so we were going to put temperature at the beginning of the sentence and just take this whole thing and flip it around backwards. So the sign stays open towards the T. We just flip around. So the temperature has to be greater than 983 Kelvin for this reaction to be spontaneous. Any temperature above that number.